Now students, the last topic of this chapter is power of lens. As you remember that lens, and I have told you many times that the diversion or the bending of the light, like the concave or convex, this is the convex lens. Now according to this, how you are going to decide that light is going to bend with what angle? Yeah, so this would be decided by two things that I have said to you. Like, let's suppose this is one convex lens and this is another convex lens. So now where and how this is going to be decide that which is going to divert how much the light ray that is coming and with what direction, with what angle it is going to be bent. So it depends upon the power. And how that is power going to define? So it depends upon the two things. One is the material of the thing that we are using, and the another thing is the size. As I have told you already, these two things are very necessary. Material, okay, let's suppose that these two lenses are made up of same material. Fine. So same material is used, but if we have kept the size different, one is more thick and one is thin. So these two accordingly are going to bend the light ray in their angle, in such an angle that the light ray are going to meet at a point that is known as focus. So here for the two things, let's suppose this is the thicker lens and this is the thinner lens. Okay, I'm making two lenses. Thick lens, these two are convex one. Okay, but this thick one is going to bend the light ray more. Okay, and quick. So the focus point would be here only, because the light rays that are coming parallel are going to meet here only. But the thinner one is going to meet it little far. Okay, so the focus point for this one is here, though the material is same for both the cases. So here we are going to define the power of lens, that this lens is having different power 1, let's suppose, and this lens is going to have the different power 2, let's suppose. And now for the formula of the power, how we can define the power in a single term, like if we want to derive a formula for the power of the lens, what it could be. So you remember that the focus point for the things, for the both objects here is different. Okay, that is going to define the power of particular lens, because you know that focus is the only quantity that we are getting. We cannot see the material every time, we cannot observe the size every time. Like this is thin, it could be more thinner, it could be little thinner. So how you are going to define? It depends upon the focus where it is going to meet, the lights are going to meet. So now this one is going to define the power of this particular lens. Yes, so this is what the power of the lens, that is the reciprocal of the focal length that is taken in the m. M is here meter. So according to that, the formula would be is this one, 1 upon focal length, that is the reciprocal of focal length. Now the power, it's inversely proportional to the focal length. So we can say that power is inversely proportional to the focal length. More the focal length, if focal length is more, power would be less. Yes, more the focal length, so power would be less, because power is something that gives you an idea that how much the light is going to bend, with what power the light ray is going to bend. Okay, that is the power of the lens. This thicker one is going to bend the light more, so it is having more power. That is why it is having less focal length. So focal length if less, so power would be more. So this one is the example for this one, and this one is the example for this statement. So I hope you understand this thing. What is the formula for here is, in a short form, you can write P is equals to 1 upon F. And the SI unit, you know that the focal length is going to be measured in meters. Here the standard one is meters, because in science, in terms of physics, we always keep length size in meters. That is the appropriate thing, standard one. So according to that, 1 upon F is going to be 1 upon meter. So meter inverse is what we can say the SI unit for the power. But as here we have coined a term for this one. So meter inverse is, you can say, as the diopter that has the capital D symbol. So this is what the power, and this is how it is going to measured. I hope you understand this one. So let us do one example out of it. So here is the example that we need to perform according to the power of the lens, and formula you remember. So here, suppose for a concave lens, here we are taking concave lens, focal length is 25 centimeter. What is the power of lens? Now, according to the situation, you need to change the focal length. Plus or minus sign should be kept in mind that for concave lens it should be positive or negative, and for convex lens it should be positive or negative. Okay, so now you remember that concave lens, in case of this, we are having, this is the diagram, and according to that the rays are coming like this, parallel, and diverge it like this. So the rays, it seems like they are coming from the point behind. So this is taken as the focus 1. So now this is at the left side. So the focal length here in case of this would be taken as negative. Okay. So let us see the thing what we have written here. So you know that the concave lens is having negative focal length. So minus 25 centimeter. Now here you know that minus 25 centimeter. Centimeter is need to be changed. Why? Because we always take the thing in standard units, that is meter. So convert this one into meters first, then you are going to use it. Okay, so focal length must be in the meter form only. So here, because it was in the centimeter, we have divided it by 100, and that is going to give the answer as the minus 1 upon 4 meters. Now the focal length is in the meter. Now we are ready to put it in the formula. Okay, so formula was this: power is equals to 1 upon focal length. Now as it is, this number is going to be inserted here, 1 upon 4. Okay, so it is going to be like this, and when reciprocal, so this will come on the numerator part. The answer would be minus 4D. So this is how, according to the situations, you can find out if it was the case of convex lens. Okay, so accordingly you have to put the focal length as the positive. So this was the one example. Now let us see one more thing, that is the power of combination of lens. You remember that lenses are kept like this is one lens, and if I put one more lens here, so I am adding one to another lens. So here, according to this diagram, what we can do, we can just add on the power for these two one. That is the combination of lens. So accordingly, we can find out the power for the combined lens. If one or more than one lenses are used together, it is called combination of lenses, like I have shown you here. Okay, so if we want to find out the combination, so individually the power of this particular lens, the power of this particular lens is going to be added. It is as simple as it is looking like. Okay, so the formula for this one would be P. Total P would be P1 plus P2. Okay, so this is the power, total power, that is you can find out. So here what you need to know, you need to know only the power for this particular lens, and if there are 2 or 3 more, so just find out the power for particular individual lens and add on in the last, so you will get the combined of the lenses. So students, this was the last one, and here from out of this you can draw a lot of things, practical applications, your MCQs, your question and answers. What you can see that different questions can be asked, and these are not going to be asked directly, but it is on the concept based. So your concept must be clear before giving the exam, and for that you need a lot of practice. So remember the things, the key points that I have told you in this chapter, and focus on the question and answers part. Try to get different questions and then solve it. then only you would be able to get a good marks in exam. So all the best and keep learning.